This data here represents an attempt by a researcher to look at the relationship between the number of hours that people spend on social media and their loneliness. So our question might be whether the amount of time you spend somehow makes you more lonely or makes you less lonely. So we're looking here for a relationship. We're not looking for a difference, we're looking for a relationship. We're seeing whether if somebody's hours spent is in any way related to their loneliness. And because we're measuring relationships here rather than differences, the appropriate statistical test to use is some kind of correlation. But we don't know which. I mean, there are two correlations that are usually in use, two familiar ones for everybody. There's the parametric Pearson correlation and the non-parametric Spearman correlation. So the first thing we need to do is to determine whether these data meet parametric assumptions. Well, hours clearly is a ratio scale, because if you spend no time if you represent no hours on social media, then that means you've spent no time at all. So 0 is truly 0. It's a ratio scale. Loneliness is the score of a questionnaire, and these are the total questionnaire scores. Whether 0 means whatever 0 means no social contact at all, the bigger the score here, the more lonely you are. So what 0 means is not necessarily that clear. So we could say that this is probably an interval measure. So we can probably use a Pearson correlation, because the data are okay to do that, so long as the data meet other parametric assumptions in terms of skewness and outliers. So let's have a look at that. So analyze here, let's go to descriptive statistics and frequencies. If you're used to doing obtaining information through the Explore menu, that's fine to do that. You can get skewness statistics to do that too. So let's move both of these things in here because we want to know whether both of them are skewed. Let's get some charts. So let's get a histogram and click this normal curve, so it gives you some idea about whether the data are normally distributed or not. Continue. And then statistics, we want just to begin with to ask for skewness. When you're measuring relationships, you're not really comparing means, so means aren't that helpful. It might be worth reporting them just to give you some idea about where people were scoring, where people tend to score high on hours or low on hours, but we're not comparing means, so that's not as crucial. We're looking for a relationship. So we've measured skewness, and we can simply say continue, and then OK. So let's have a little look at the graphs first. Well, the first one here, this is the number of hours spent on social media. It doesn't look terribly normally distributed just from looking at the way that the data are. But remember, data, particularly when you haven't got many participants, doesn't normally follow a beautiful kind of bell curve. In fact, if you look at the curve here, it shows a modest positive skew. Remember, positive means that the tail of the distribution is more towards the top end, the higher scores. There seems to be quite a lot of people here who don't spend many hours on it, which is what's dragging these numbers down to produce this positive skew. But we need to know, by looking at the statistic, about whether this is too skewed to do a parametric test or not. Looking at loneliness, this time we've got a modest negative skew. In other words, the tail of the distribution here is down towards the low end. We've got some gaps here. A lot of people tend to be scoring kind of in the middle and towards the top, with not many people showing high degrees of loneliness. So these are important when thinking about data, because quite often if you give people a questionnaire, in certain cases you might find everybody's clustered either towards the bottom or the top. And if there's not much variation in scores, everybody's kind of scoring the same, then sometimes you might not get a significant correlation there, just because there's not enough variation in the score. So that might be arguing that you need a different kind of population, or maybe more participants. So both of them look like they're probably okay, but how do we know from eyeballing? Well, years of experience. But for a better test, if we look at the skewness statistic here, remember, if we multiply the standard error of skewness by 1.96, if that number is bigger than the skewness statistic, then we say it's significantly skewed at a p less than 0.05 level. We don't need to do that to know that 2 times 0.3 is not going to be it's not going to be lower than 0.23. It's going to be a lot bigger. So the skewness statistic is okay here. Similarly, multiplying 0.31 by 1.96 would produce something bigger than the skewness statistic here, 0.46. And remember, this negative here simply means that this is a somewhat negatively skewed but not significantly so distribution, and this means this is positive. And if we go down here, indeed that's what we see. Time is positive and loneliness is got a small negative skew. So this suggests that we can do a parametric statistic, but let's just have a final check and see if there's any outliers in these two conditions. So we go to graphs, legacy documents, and box plots here, like that. We want to do, because we've got a within participants design here, if you like, each Persian being measured twice, we want simple and we want summaries of separate variables. So the second option, and then we simply put the boxes represent those, and we click OK. If you wanted to, if you had a between participants design, then you would do summaries for groups of cases, and you need to put the condition in a second box there, which is shown on another screencast. So we click OK, and we get the box plots on a nice graph there. And what we can see here is that there are no scores that lie outside the whiskers, and the whiskers here is 1.5 times the interquartile range. So that means everything's okay. If there were people outside here, then we would need to do probably a further test, which is shown in another screencast about dealing with outliers, which determines whether the outlier is a significant problem. Is the score extreme enough to warrant us having to do something about that individual, or use a non-parametric test indeed. Okay, so the data are entirely appropriate to do a parametric rather than non-parametric correlation. So for correlations, we've got to analyze, we've got to correlate, and we've got to bivariate. We simply put both of the variables in there because we're looking for the relationship between both of those two, and we make sure we've got Pearson checked here, and we stay with the default at two-tailed. Click OK, and then what we get here is a table of correlation coefficients. Not terribly helpful sometimes the way these tables are laid out. It tells us how many participants there are, but look, obviously hours correlates perfectly with hours because it's the same variable, so I don't quite know why SPSS gives you that, and similarly loneliness correlates with loneliness perfectly here. The critical one is here, hours with loneliness, and the correlation coefficient is 0.28, if you're rounding up to 2 decimal places, which is the traditional thing to do with correlation coefficients. And it's significant here. The significance level is smaller than the usually accepted p equals 0.05, so we would say that there's a significant relationship. But when reporting a correlation, it's important not just to say there was a significant correlation. You need to also say which direction the correlation was. Did increased hours using social media lead to more loneliness significantly, or did it lead to less loneliness? And we can see from this correlation, because it's positive, there's no negative sign here. It means that social media use seems to lead to people to become more lonely. Now, I've just immediately picked up on an error I've made there, because obviously what I was doing there was making a causal attribution. I said social media use leads to people becoming more lonely. From a correlation, and there's more information, it's on the website about inferring causation from statistics. For correlation, you cannot make a judgment about whether it is the hours on social media that's causing the loneliness that's causing people to use social media more, which is a perfectly reasonable idea, or maybe some underlying third variable is giving rise to both of them. So I've got to pick myself up on that, and remember, pick yourself up on it too. There is a significant relationship, but we don't know where that relationship comes from. So there's a significant positive relationship, but how big is this effect here? Well, we can see if we consult Cohen's tables that this is a weak relationship. I think anything below about 0.3 is a weak relationship between the two variables. If you wanted to convert that to variance, then if you multiply that by itself, you'd get something like 0.8%, so 8%. So 8% of the variance of one variable is accounting for, so one variable is accounting for 8% of the variance of the other. It's a small effect, but maybe still meaningful. So when you report a correlation, you comment both on its significance, is it reliable, but the strength of the relationship, which is kind of a measure of effect size, is it weak, moderate, strong, and also the direction. So you might say it's a weak, positive, but significant correlation between these two variables. If you wanted to do a scatter plot, people like to do scatter plots sometimes. Sometimes it can be useful. Quite often there's no point in putting these in a lab report, put them in the appendix unless there's something very interesting about the scatter plot. Let's get a scatter plot then. So legacy docs under graphs again, and then we go to scatter dot here, simple scatter, and we define, and we've got an x-axis which is the one going up, and a y-axis the one which goes across the bottom. Simple way of remembering that I use is y's up, and then OK. And we can see there that it's a bit like somebody's fired a shotgun at a door, but there's a sort of positive relationship. It's generally kind of going up here, although you can see it's a weak relationship because there's a lot of kind of, this person is scoring very highly on the hours, but isn't scoring very high on the loneliness. Okay, so people aren't falling into line particularly well. The reason for using scatter plots is sometimes you can get what is called a curvilinear relationship, which means that there's a lot of people scoring low on both, and then there's a lot of people, so you almost get like what's called an inverted U shape. Now that would show up as being no correlation, but it would show that there's a relationship. It might show that people who are very low on social media have kind of are very lonely because they basically don't have any mates on social media. People who are very high on the number of hours may also be very lonely. So it's important to look at that sometimes.